Hi Ankur, can you hear me?
Yeah. Yeah. Hi, Suresh. Yeah.
Okay.
So, good evening, everyone. So, this is Suresh. He's a TA for this NPTEL course, Introduction to Photonics. And if you like, he is particularly assigned for this week 9. So, whatever doubts you have, you can resolve through him. Okay. So, Suresh, is it audible? Like, any idea
Yeah,
issue?
I can hear you, Ankur. So
Okay.
I see Anirudh and Sana are here. I think your voice somewhat was breaking down. Some part of your voice, some part of your voice. So
Yeah.
otherwise, it's fine for me. So if any questions are there, I can take over actually from this week. Yeah.
Please. Anirudh, if you have any questions, you can ask. Sorry for the inconvenience. Whatever, you are not hearing my voice properly. Voice is breaking. Uh, yes,
Anirudh and Sana, are you there?
yes.
Ankur, I think some voice, some
Yeah.
voice issue is there. Like
Uh, I think now it
lot
is
lot
clear
of
now.
distortion is coming out.
Now also it is coming, distortion.
And now it is fine. Yeah, now it is fine.
Yeah. Okay.
I don't
So
hear any
guys,
questions from the students.
yeah, please wait.
Oh,
Let
your voice. Okay, Anirudh's mic is not working.
okay.
So I'm not sure how can we communicate with him.
Yeah,
If there
text.
is any questions with Sana, we can take up.
Yeah, you can type also, Anirudh, no issue.
Anirudhan can type, but I did not understand the impact ionization works. Okay, that's fine. Mm, I did not understand how impact ionization works. Okay, okay, Anirudh, what happens? Maybe I can just share my screen.
Yeah, you can say, please. I'll stop my screen.
You can see my screen, right? Okay. See, actually, what happens with the impact ionization in diodes, photodiodes, let's take, no, so this is P, and then again there is P. So now you see there is see the electric field, isn't it? Simple APD. You see the electric field at this junction is too much high. In it is in the order of 10 power 4, 10 power 3, centimeter per volt. Volt per centimeter. Correct. Okay. Now, what happens here? Due to this heavy electric field, when we do reverse biasing to this junction, okay, when I do reverse bias to this junction, the depletion region in this PN junction, this will increase. Okay. So when this depletion region increases, the electric field strength in this depletion region increases. So depletion width increases. As a result, the field, so the E field gets increases. Okay, so when you increase the reverse bias, this E field further gets down and it breaks the junction. So what happens in this case, like the electrons or the the impact ionization happens when the electron fills the hole or electron moves away from the region, depletion region. So in this case, when you increase the reverse bias, this impact ionization will the causes this electrons get multiple times. Okay, so this multiplication of electrons is called as avalanche multiplication. So it will increase the carriers. The carriers will get increase. So this is called as impact ionization. This ionization here is like electron hole recombination. Okay, electron hole recombination. So hope you have understand the field strength. So did I answer your question somewhat? Anything? Hello, Andrew. Ankur, are you there? I think.
Yes, can you see the chat? Uh, he's telling that
Uh,
yes, sir, but I didn't understand that part. How is it multiple times?
oh, okay. So that multiple times actually due to the electron hole pair generation inside this junction. This heavy electric field junction is there. So due to that, when you increase the reverse bias, the potential across this barrier, the potential across this barrier will increase. The field will get increased due to this heavy electric field. The number of electron hole recombination will increase. Okay. So due to this, the electrons, the electron multiplication happens due to this heavy electric field in this direction. Okay. Um, so I'm not getting the question clearly. Like see, this is actually due to the heavy electric field and the electron hole recombination at the junction, and that actually causes the multiplication of ions together. That is due to this, mainly due to the electron hole recombination. Otherwise, the junction may not actually form here in the depletion region. If we can speak out so that we can communicate very clearly. But I'm not sure. How to check the chat
Are
box.
you getting Anirudh some like clarification? You can
Maybe I'm
can you
not.
ask me?
I'm not giving total picture of that.
Yeah,
Maybe I'm giving some reasons like how this impact ionization happens in the on the APD.
please you can
Yeah,
join
yeah,
from
sure,
that.
sure. Please join from phone then so that we can discuss. Ankur, typically, how many students used to come?
Typically like 5 6 students, but this time I think some issues there maybe. So
Okay. Mhm.
maybe some students will join within just 10
Mm.
20 minutes possibly.
Okay. Actually, the carriers is swept away from the depletion region. Okay, in this case. And when the electron hole pair recombination increases, the multiples of electrons will come out of the junction. As a result, the current increases. I think Rahul joined this now.
Yeah, he
Rahul,
joined.
do you have any questions? Yeah. Rahul, can you hear us? Hi, Rahul. I don't know what happened. No.
Maybe some issues there. So if you have any doubts, Rahul, you can join. You can ask.
I think Anirudh joined from mobile phone. Maybe Anirudh can speak out to continue the discussion further.
Hello, sir. Am I audible?
Yes, yes, you are audible, Anirudh. Can you just
Uh, yes, sir. I didn't understand like how the momentum, like how does impact ionization actually increase the response time? That is one question I had, and the other thing is like why because of high electric field that the electron hole pair is more how like when the light is incident from the left side, how does it affect the end? Like why is it in the right hand side? Why not in the first side itself? Like the left hand side itself, there's another pair that I didn't understand.
oh, left hand side, how the another pair can't be formed, right? This is actually a P region. You can add, you can add N layer to the P region.
Yes, sir. There, what if it was added there? So I didn't understand why it was added in the right hand side. That if you can clear up that concept, it'd be nice.
Yeah, yeah, that can also be possible. I think, maybe in advanced studies, if you even if you add N layer to the P side, that will also create electric field in this right in this direction, right? Now the field strength will be looking like no this way, isn't it? But why we add P layer to the N side? You know, maybe this, electrons in the in majority of the carriers in N-type semiconductor is actually electrons, right? Maybe that is actually close to the voltage or the electric field that we apply. But where you place the N region, N-type semiconductor to the hole, near to the hole, the field which forms at this junction may not be strong as same as at this junction, since the N is actually inside the material actually. Maybe the layer is in between. Let's see. So this is N layer. Now you're saying this is there is a interesting region, and then again N layer, and this is P layer.
Sir, hello, sir.
Yeah, yes.
Uh, hello, sir.
Yeah, yes, I can hear you. I can hear you.
So, like sir said that when the photon passes through the PN, the junction diode, its magnitude exponentially decreases according to the alpha constant.
Oh, yeah, right.
But then at the end, because of the PN junction combination, the second combination, there's an increase in electric field. You're saying, and the electron hole pairs are generated. So
Hmm.
how is that creating more electrons? Like, why more combination? Why multiple times? That I didn't get. Like, what is impact ionization? What exactly happens? I didn't understand. I've been only through two lectures now. So I don't know if it's covered in the later lectures.
That actually professor covers in second lecture or third lecture, that impact ionization of the holes and electrons, right?
Oh, okay,
Did you
okay.
see that? Did you see that?
No, no, not yet. I have only been through the first two lectures.
Okay, you can actually go through that. See, the
Okay.
first of all, like impact ionization, if you say like don't worry about the photons which are actually instanting on the APD first. Okay, so
Okay.
the impact ionization is actually due to the material property. Okay, first of all, and what is the impact ionization of the holes and the electrons when we compare for a particular material? So which one is higher? So whether the electrons having the impact ionization higher, or holes are having higher impact ionization? That is what the placing of this, as you mentioned, as you mentioned, that why can't we add this N layer to the P side? Okay, so that actually, as I mentioned, like the majority of the carriers in N type is electrons. If the electrons ionization, the ionization coefficient for the electrons is higher than the holes, then it actually works. Otherwise, if the holes having the impact ionization higher than the electrons, that may not work better. So this is how that we add the layers, the extra NRP layers to the existing PN or PAN diode to make an APD.
Okay, sir.
Maybe those things will come into lecture three. I think that photo detectors three, lecture three. Uh,
Okay.
yeah. Any further queries on this? You can just ask. Ah, yes, sir.
Yes, sir. I had a doubt which is related to actually the ending of first lecture. The
Uh-huh.
professor said that when you introduce that I layer in between and when it's like quite long, then
Mm.
generally there are two quantities which are changed. One was the responsivity and one was the response time. So in the end, he mentioned that the responsivity is increased as the length of that I layer is increased, as well as he said that the response time is decreased. So uh, I found that kind of counterintuitive actually. Was that a mistake
Exactly.
that he said? Something like
No,
that?
no, no. That's not a mistake actually. Uh, Right. You mentioned like in PI and diode. Okay. That PAN diode actually what happens, we add an extra intrinsic layer between P and I. Okay, it is actually called as a resistive layer.
Yes.
So what happens, the carriers, when the carriers actually move from P to N or N to P, they have to travel a long distance, and the speed of these carriers may reduce due to this addition of the resistive layer. Okay, the velocity, the drift velocity, or the drift velocity of the carriers. Due to this, the response time will actually go down. The response
So,
time.
sir, basically, what exactly is the meaning of response time here? Does it mean that how fast that thing will react
Yeah,
to
that
that
is correct.
incident?
That is correct. The response
So
time.
that means we
Yeah,
prefer that the response time should be lower, right?
yeah, response time is lower. Yeah,
So basically, when we introduce this resistive layer, so both of the things which are happening, they are both better for us, as far as I understand by this sentence.
right, right,
Uh,
right.
so when he was saying that you gain one thing at the expense of another thing, uh, so these two sentences are actually kind of I'm finding these contradicting in some way. That is this thing a better thing for us that our response time is decreased, or is it a bad thing when we compare it with the responsivity of that particular material?
Okay. So you actually, yeah, what we understand, like what you understand is like the response time is like how speed the device will respond to the incident photons, right?
Yes, sir. Yes.
But but what professor was saying, like you are thinking like the response time decreases. This is actually drawback
Because
on.
initially he talked about that if you increase the responsivity,
Uh,
basically you have to pay for it in terms of response time. And by the end of the lecture, he said that your responsivity increases and response time decreases. So how I see is that if both of these things are happening at the same time, then increase in responsivity is also a good thing according to me. And response time decreasing is also a very good thing because it's that thing is working fast. So am I missing something?
no, you're not missing. I think yeah, that's a good question actually. The why the response time decreases, that is actually good
That
for.
means that thing is working very fast also, as well as its responsivity has increased. That means it is also capturing it in a better way. So there is no shortcoming as far as I can see when you introduce this I layer.
I think he's actually mentioning this response time in some other context. I think. So what we are thinking like the speed is increasing due to the response time decreases. But I don't think that is, yeah, wait, maybe the response time. He's saying like that will actually slows down the carriers. That will slows down the carriers. That's what he was mentioning actually. This response time is not related to the what we are thinking. Because by the addition of this resistive layer, what happens? The velocity of the speed of the carriers will actually reduce. This is what
Okay.
he is mentioning. I think that if the speed reduces, the time which they take, like that will actually
That should increase according to me. That's how I was expecting it to
that
happen.
increase. Yeah.
So that is why I was a bit skeptical about this statement that the response time is also decreasing when you introduce this I layer. So that might be, he might have said that mistakenly at the end of the lecture.
Response time. Okay, I will actually check that. Okay,
Okay, sir.
we'll check that, and maybe I
Because
will.
throughout the lecture, he was saying it correctly as far as I can see. But at the end, when he was just kind of reiterating it maybe he said it otherwise. So that is why I felt it doubtful.
Okay, okay. Can you put this question in discussion forum?
Sure. Okay.
We hardly see any questions in the discussion forum. Maybe if you can put that in discussion forum, like maybe people will come answer.
Okay. Okay. Sure.
So this is what I thought actually. You understand, right? What I was actually mentioning to you.
Yes, sir. Actually, this was the picture in my brain also initially. That is why I was feeling a little skeptical about this.
If the response time decreases, that is good for us, but I don't know why response time. It is
Not
not
supposed to decrease
it
actually
is
in this height.
right. It is sure that the speed of the carriers will decrease due to this
Yes, right.
additional resistive layer.
Yes.
Uh, but response time decreases means like it is good for us, but in what context R was mentioned, I also have to recollect that thing. Okay. Yeah,
So
thank
you
you for
can
your
just
question.
check the end of the first lecture. It's just the last few 10 seconds only. You will find it.
Okay. Ankur, do you have any answer for this?
We have to think actually, like discuss in discussion forum, that will be better.
Yeah, that will be better actually. Professor was also mentioning that
Actually, sometimes
there are
professor
no
what
questions.
whole things he will explain in the end. Maybe he gave some hint. You just stick with that point. Maybe we'll check that and we'll let you in discussion forum. You ask this question.
Okay, sure.
Yeah,
Right.
yeah.
This
Sabapati
is,
will. Yeah. You have
right.
any questions, Sabapati?
Sabapati is here, yeah. Yeah, Anirudh's question also was good and Rahul's question was also good. Yeah, yeah, it's Mr. Sabapati.
Yeah. Hi.
Due to the reduced speed, time taken to travel from N to P is increased, sir, I think.
Right, yeah, that's right. That's what actually Rahul was.
Yes, sir, yes, sir. Speed is decreased, response speed is decreased, so response time increases, I think.
Hmm,
Right, right. So I had, sir, one more doubt basically.
yes.
In like in question number 9, the last option states photo-electron conversion. It's
Ah,
talking about the response time. So,
mm,
what exactly, which part is called basically photo-electron conversion? It is just that absorption of the photon which is ejecting an electron, or is it
yeah,
a normal?
that is the one. Right.
Okay.
So,
So, uh, because generally, like when we talk about photoelectric effect, that's kind of like an instantaneous thing only. But in this PIN case, it takes a like exponentially that thing starts to decay and it gets absorbed. So
exactly
we are
that.
talking
Yeah,
about that, right?
yeah, that part only.
Okay.
So this is correct actually. This question actually makes you think of it like what the response time of a pin diode is limited by, right?
Yes.
So
It
you
makes you think about various factors actually. It's a
exactly. Mm.
looks, but it's a very long question actually.
Yeah.
You
So the
have to see
response,
all the facets of the same.
but as per our conversation, response time will actually decrease, right? Or
Yeah,
increase
yeah. It will response time will basically increase because of that layer.
because of that layer. Because of that layer, the response time increases. No, that's no. That the carriers, carriers moving from one layer to another layer with low speed. Low speed means time will increase, right?
Yeah, yeah.
That time will increase, but the response time. What happens to the response time actually?
So, sir, what exactly is basically how exactly should we think about response time? Exactly in
Yeah,
this case.
right, right. I think what I'm. You can see my screen or.
Yeah.
Just a second, I'll just,
Yeah.
now you now you say it.
Yeah.
Yeah.
Mm. So maybe now I got the point actually. Mm. See, this response time is not related to the time taken by the carriers. Okay, so time taken by the carriers is not same actually. Okay, both are not same. So the time taken by the carriers are actually increasing due to the resistive layer. So, but what is the response time? See, the response time is actually, I think this is again, as we mentioned, like when the photons incident on the material are thin photodiode, uh, what happens? This will actually create electron hole phase generation. That the process of electron hole pair generation, the time taken for this generation, if it is in very less time, if it can convert the light into the electrical signal, you will get very fast response, right?
Right.
Right. What happens? This response time is, I think the fast response actually the response is becoming slower. That is what he was mentioning actually. I think the response becomes slow when we add additional intrinsic layer. The carriers time taken by the carriers will actually goes high. So that means the carriers are moving very slowly. In that case, when the photons incident on this I layer, the electron hole pair generation also will slow down. Okay,
Yeah.
this is what I was actually thinking. Maybe not response time. I think response becomes slow. I think not response time. I think this time actually making confusion.
There are two things, no, sir. One is the responsivity, that
It is.
how good it is responding, and one is how fast it is responding. That's the response time.
Mm,
So in terms of responsivity, it is definitely increases because of the eye layer. The photons get a larger area, basically depth-wise, to get more better absorbed.
right, right.
That
More
is
photons will.
correct.
Yeah. Mm,
Yes, but when we talk about the response time, we are that is where my doubt is basically what time is called response time, because initially at just the entry also some of the photons will get completely absorbed, and they will generate an electron hole pair, and part of those photons will take a longer time as well as longer path to get absorbed.
right,
So
right.
the time taken for generation of an electron hole pair it will be different for different photons,
Mm,
and the material is still same.
mm,
So are we taking an kind of an average, like where large number of photons have been converted to electron hole pair? Should that be called a response time?
mm. Yeah.
Because there are many scenarios happening at different moments of time whenever they are being absorbed.
Mm,
So will we just count it on the basis of the fastest one, or will we count on the basis of the last photon that is being absorbed at the later period of time, which we just take as a input pulse as an reference?
mm. Uh,
So basically, the definition of the response time is kind of
puzzling here. Okay. Mm. Yeah, maybe we can actually discuss in the discussion forum and then let's hear the voice from the professor.
okay, sir, sure.
Maybe if it is not clear, maybe by next week I will come up with the answer.
Okay, okay, no problem.
Right. Any additional things that the other students can add to this point, like what Rahul was mentioning?
Actually, you should ask some questions in discussion forum as well. So it is better to we can see and we can answer according to that. We'll just take a look on these things and
Right.
directly we can text there. And after that, that things also we can discuss here in the group, this live session. That is also possible.
That should be a better act. So when you ask the question directly in the live session, we may not have the proper answer for you. But if you type these questions in the discussion forum, we will actually come up with a good answer for you and make you understand no, very clearly. That is where we are actually. That is where the discussion forum is lacking currently. So there was a question by Abhishek previously. He was saying like why we can't add the N layer to the P side? Why we are adding P layer to the N side to the APD? And what is impact ionization? How this impact ionization increasing or decreasing? If we add the N layer to the P side and all, like he was thinking in a brilliant way. This is also a very good question. Like the first question that has been asked by the candidate Abhishek. Yeah.
Yeah. So any other questions?
Yes. Any other
Yeah.
questions?
So related to the week 9 assignment, if you have any questions, any doubts, you can ask also.
I hope that you are actually started solving this week 9 questions. I hope you have already gone through that. Maybe some of you are listening the lectures first and then solving the questions later. Maybe any questions related to the week 9 assignment as well you can ask. According to this week.
This week you have given 13
Yeah,
questions.
13 questions were there because the content of this week is huge.
Yeah.
I think you have noticed that.
Yes, sir.
So that's why we gave around 13 questions in this week.
Yeah.
The marks will be basically normalized on the basis of 10 only of this thing.
Uh, Not like that. If these are 13 questions, 13 marks. But at the end of the report, there was all the marks. Mr. Sabapati, do you have any questions?
No, sir, I don't have questions, sir.
Oh, okay. Ankur, what we can do now? We can,
Yeah. Thank you so much, uh,
yeah,
Suresh.
thank you so much for
For yeah,
participation.
yeah.
Yeah.
If they have doubt, I will keep live this session. You can leave if you're
Right,
like
right.
questions
So
are not there.
I request the students to follow the discussion forum and ask the questions in the discussion forum. Very diligently, and so that we can answer them. Even professor also will involve in that. Professor may not be having the time to join every live session on Saturday. He may join, once in 2 weeks or once in 3 weeks. Then he will come up with the proper answers also. Yeah. Thank you. Yes.
Okay, Suresh. Thank you so much for joining.
Yeah.
Yeah. So, guys, if you have any doubts, you can type here, sir, in message in chat box, and we'll keep sometime live this thing. So I'll go through these questions. If you have any doubts, you just tell me. Actually, by professor, it is clearly mentioned that I should not solve these questions. So just I'll go through it, and better you should go through video lectures, and one by one you can solve, because whatever the questions are here, everything is taken from the video lectures. Okay, guys? Yeah. So this is question number one. Question number one is saying the assertion PN photodiode better provide better responsivity without compromising fast response compared to PIN photodiodes. And the reason is given that I reason that is under the influence of diffusion and hence slow down the PIN photodiode response. So if you have any doubts, you can ask directly in the discussion forum. It is there. Ask a question, um, uh, like a button in the Swayam portal while you will open the course. Okay, so there you can ask directly. And this is the second question. Match the following physical parameter of the photodiode with the corresponding physical description. So column A and column B you have to match. Short noise, thermal noise, diode current, efficient photocurrent extraction. And column B is given that electron flow inside a resistor, random arrival of electrons, thermally activated carrier under no light, inversely proportional to the load resistor, and a trans impedance amplifier. Then question number three is they consider the plot below between the multiple factors M, multiplication factor M, versus the electron ionization alpha E omega M in a SI-APD for different values of the ionization ratio K. Which of the following relations hold good for the given graph? So here, like some K1, K2, K3, K4 is given, and according to that, you have to mention here this uh, tick mark is like square box where you have to mark. So you can understand this is a MSQ question. So according to that, you have to go through it. Then question number 4 is there. If the absorption coefficient of silicon is 0.05 per micron at 860 nanometer, then the penetration depth would be in micrometer. So just follow this lecture, you'll get the formula and you can solve this question easily. Then the question number 5 is the impact ionization coefficient for holes is greater than that of electrons in silicon. So true and false you have to do here. True or false. Then question number 6 is there. Yeah. So question number 6 is saying that suppose an APD with a responsivity of R is equal to 10 ampere per watt operates at a wavelength lambda is equal to 1550 nanometer. To achieve a quantum efficiency value eta of 0.8 at its operating wavelength, the multiplicative gain loss would be. Again, this is the numerical questions. You can solve it very easily if you follow this lecture. APD this lecture, okay? Responsive times and all. Responsivity and responsive time. Then question number 7 is there. The response time of a PIN photodiode depends on transit time and the RC time constant. Which of the following would be the best way to design a PIN diode with a very less response time? So This is I'm just checking. Is it a MSQ or MCQ? I'll check. Yeah, this is also a square box, so it is also MSQ. Question number 8 is also MSQ. So question number 8 is which of the following statement are true about the avalanche photodiode? So this is also MSQ. Then question number 9 is there. The response time of a PIN photodiode is limited by. So it's a straightforward MCQ question. If Professor already have talked about this thing, so you can go through that. Then question number 10 is there. An APD with zero impact ionization ratio K is characterized by. Okay, MCQ question. Question number 11 and 12 have same instruction. So suppose you are asked to design a indium gallium arsenide PIN photodiode with a 3 decibel frequency of 10 gigahertz while maintaining a responsivity of at least 0.85 ampere per watt at 1650 nanometer. Assume that the absorption coefficient is 10 to the power 6 per meter at 1650 nanometer, drift velocity of 10 to the power 6 meter per second, series resistance of 2 ohm, relative permittivity of 2.4, photoelectron conversion efficiency of 0.9, and negligible phase shift reflectivity. So the question number 11 is that the minimum width of the eye region is in micrometer. You have to say this is in up to 2 decibel. It is allowed. Okay, and another filling blanks is there. The transit time of the carriers is in second. You have to tell. So it should be like in power it should come because it value will be very less. So you have to think about this also. Like space should not be there while giving the answer. Then yeah, 13 question number 13 is there. It is a MCQ reason and assertion kind of question. In this assertion is that the SNR can be improved in an in an APD if the application factor M, sorry, multiplication factor M can be increased until the excess noise becomes comparable with the thermal noise without affecting the overall noise. And reason is given that short noise is much below the thermal noise when lower number of photons are incident on the detector. Yeah. So this is also reason and assertion question. So yeah, you have asked in question number. Okay, yeah. So you have asked question about question number 6. Yeah. Which one you are telling? I didn't get you. Question number 6. Yeah.
Is this multiplicative game? Like, what variable are we trying to find?
That is like just a second. This a multiplication factor also you can say is m you can say.
Okay, okay. Got it. Okay.
Yeah. Any other questions? Please ask any questions is there. One thing I'll do, I'll just share the screen once so you can understand how you can ask the questions directly in um, discussion forum. Okay, we can access easily, and that would be better. While you have a very minor doubt also, you can ask it. Okay, that is not an issue. We'll resolve that issue. So it is for you guys only. It is not for us. We have to teach, but you have to learn. That is our main motive. Okay. So ask as many as questions. Okay. Here you can see this. This is the window of Introduction to Photonics course, and here you can see this ask a question is written. Okay. This you have to dub your question here. Okay. New conversation you can ask or directly. Yeah, new conversation is the best option. Or group wise you can ask whatever you have. I think it is not applicable, but new question. Yeah, your name and all these things you can ask directly. This Uma has asked so many questions. Previously, okay. Please ask as many as questions you have. Previous weeks also you can ask. There is no issue.
Ankur, when will be these questions will be answered?
Will be like these questions after your assignment will be completed. The deadline is like 27, I think. Yeah, so 28th it will be live. Like all these solutions will be live. Okay. So
No, no,
before
no.
that it
The
is
questions here some questions are posted the previous some participants,
yes,
but
yes, yes. Already
uh, the,
all the questions are given. Answers are given already.
some are like inactive. Like here we can see top five are inactive. Bottom three are active. Like that, they will be no. Is not like that.
This actually this suppose this Oma Maheshwari has asked one question week 8 assignment
Hmm.
question number 7 that I already reply to her. Maybe it is not here.
No, once we see this one September 19th one, go to
Okay.
September 19th Venkata
Yeah, yeah.
Sai one.
Okay, okay.
That is not answered, right?
Okay. I think it is to directly to professor and he directly reply to author. He did that. Maybe he should do in the reply all. That will be very good.
Sorry, sorry. So is it
Thing is
answered?
like yeah,
Is this answer?
there are two options here: reply all and reply to author. This Demenkatis. So it is it you or
Me.
like
It's me. It's
okay,
me.
okay, you. So did you got through professor this answer?
No, I didn't. I hope I didn't get anything. I
Okay,
think so.
please give us like I'll just convey to professor
Recheck once.
and
I
he
will
will
recheck
reply. Yeah.
once. Better I will recheck once
So
before.
I didn't. Okay, okay. This video you have posted already. Okay, I'll go through it and let you know, like in this reply itself. Okay,
Okay,
there
okay.
is no issue.
Please.
Yeah,
Thank you.
I think someone forgot to reply this one. We'll do that.
Okay.
Okay, please participate actively. So we'll give all the replies. Okay. Yeah. So thank you so much for joining. If you have any doubts, I will be live here. More like at least 10
Okay.
minutes.
So
You can ask.
before that, this assignment, if we have any queries regarding this one, where should we post to you, sir?
Queries
Ah,
regarding this nine assignment nine. You're telling.
I said net nine.
Yeah, you can ask directly here in discussion forum itself. Otherwise, I'll
Mhm.
give a link that will be. I think it is useful for you. Directly, you can ask to me.
Okay, okay. Could you
Yeah,
please
just
share
a
that
second.
link?
Yeah, yeah. Just so is here. You can open the link now itself. So while meeting will end, you will not lose this link. You will form it. Okay.
Okay,
Yeah.
okay, okay.
So this will go to directly to professor. That is the main purpose of this link. So yeah, you can ask
Okay,
here.
okay. So the questions, these questions directly go to the professor.
Yes, yes.
The link
And one more
what
thing.
you, the
Yeah,
link what
that
you provided it directly goes to the professor.
yes. Like
Oh,
to me, it will go not directly to professor. I will send to him. That is the thing. Like
okay,
professor won't get any mail or something. If you get individual mails, then it is not better to like professor having so many works also. So
mhm,
we should go through a proper channel. If it is he'll post here and any questions, I'll convey to him, and he will come in the next session and he will give the answers whatever he is there.
oh,
Yeah.
okay. Thank
And one more thing, I'll just tell to NPTEL team also to post like to mail this link to in a email
you. Okay,
to everyone who are the enrolled in this course. So you can get easily this form and you can fill your questions, your name, email ID, and question. So we'll get better, we can solve this in a better way, whatever doubts you have.
okay,
Yeah.
okay, okay.
Yeah.
Thank you, thank
So
you.
after sometimes there will be an exam also. So be prepared for that also. And one by one lectures you have to follow each lectures. All the questions are asked from there only. And most probably the questions whatever has been asked it will be repeat again also in a final exam. Some questions, yeah, almost as professor told in the last live session, all the questions will be asked from this week's assignment only, like similar to that. Okay, that is there. Okay, guys, so we'll wind up here. If you have any questions, just open this link before itself, so you will not lose this link. And maybe by Monday it will be one more time. You'll get through mail, the enrolled in this course. That mail you'll get this Google form link. Okay, so should we wind up here? Thank you so much for joining, and please be in contact and ask as many as questions you want. Okay, yeah. Thank you so much.